Today's lesson is on right triangle trigonometry. So as you can see here, I have a right triangle. So you probably remember this from geometry, but here's a right triangle, and then here I'm looking at this angle. We can call that theta. So just some reminders, across from the right angle is always the hypotenuse. And then if we're looking at this angle, next to it is adjacent, and then opposite is opposite. So we're going to look at the 6 trigonometric functions and how they relate to a right triangle. One thing you might remember to help remember this is SOHCAHTOA. And that helps us look at sine, cosine, and tangent and how they relate to a right triangle. So we're going to start with, sine of theta, so theta is your angle, is equal to, if you notice here, O and H, that is, stands for opposite over hypotenuse, opposite over hypotenuse. And then cosine of theta, AH, is equal to adjacent over hypotenuse. And tangent of theta, OA, is equal to opposite over adjacent. So that's 3 of the 6. The other 3 are the reciprocal trig functions. So sine, its reciprocal is cosecant. And cosine, that's reciprocal, is secant. And tangent is cotangent. So one thing that I always do to remember is that S goes with C, C goes with S. So just know the C's don't go together, the S's don't go together. And then it's equal to the reciprocal of all of these. So cosecant will be hypotenuse over opposite. Secant will be hypotenuse over adjacent. And cotangent will be adjacent over opposite. And then we're not going to use this part too much, but cosecant, what it is, it's also 1 over sine. Secant is 1 over cosine. We'll come back to these later. And then cotangent would be 1 over tangent. Our first 3 examples are using SOHCAHTOA to find a missing side length of a right triangle. So go ahead and draw the triangle. Right triangle has degree 42 degrees, and then we know that the hypotenuse across from the right angle is 18. So at this angle, what is x? X is adjacent. So which trig function will we use? Adjacent over hypotenuse is cosine. So cosine of the angle measure, 42 degrees, is equal to x over 18. So now solve for x, multiply both sides by 18. So 18 cosine of 42 equals x. So now we just have to plug that in our calculator. Make sure you're in degree mode and not radian mode. And when you plug it in, you should get 13.4. Anytime you're doing this, always stop and think, okay, well, does that make sense? 13.4, yeah, that makes sense. The hypotenuse is the longest side, so this would have to be close to that, but smaller. Okay, here I have another triangle, and I've got this degree, 53 degrees. Looks like we're solving for x, so we have to find the hypotenuse. And then we have this side length, which is opposite of our degree. So which trig function will we use? Opposite and hypotenuse, we will use sine. So sine of 53 degrees is equal to 15 over x. So now solve for x. We can multiply both sides by x. And then we can divide both sides by sine 53. So x equals, so all you do is type that in and you will get 18.8. If we go back up here, 18.8, that makes sense because the hypotenuse would be longer than a leg. Okay, last example of this type. Here is my angle. So this time, I don't have anything about the hypotenuse. So that right there, no, I will use tangent. Okay, so I've got, this one is my adjacent, and then this is opposite. So tangent of the angle equals opposite 9 over x. Solve for x. So this is the one where we have to multiply by x and then divide. We'll do 9 divided by tan 21. And when you type that in, you should get 23.4. Which, if you look, I didn't draw this perfectly to scale or anything, but that should make sense. Okay, the next thing is just a real quick review. When you have a right triangle, there is the theorem, the Pythagorean theorem. That is a theorem about just the side lengths, a squared plus b squared equals c squared. So this has nothing to do with angle measures other than it only applies when you have a right triangle. A and B are the legs and C is the hypotenuse. So we just are going to need this in our next example. Okay, so our last examples, you'll be given this here. So like cosine of theta, cosine of an angle is equal to 2 over 5. So with that information, can you find the remaining 5 remaining trig functions? So I'm going to start by, let's just sketch a little triangle, right triangle, and cosine, I'm going to make this theta. So cosine is adjacent over hypotenuse. So that means this 2 is adjacent and the 5 would be hypotenuse on a triangle. So here's hypotenuse and here would be adjacent. So now if we're going to write the values of all 6 of the trig functions, we're going to need to know this side. So we're going to use the Pythagorean theorem. So what we're going to do is 2 squared, there's my A, I don't know my B, and here's my C. 2 squared plus B squared equals 5 squared. So B squared equals 25 minus 4 is 21. So B is equal to the square root of 21. Once you have that side, we can now write all of these. Well, we already know cosine is 2 over 5. And then its reciprocal is secant, so we just flip that to 5 over 2. Okay, sine of theta, that is, let's see, so opposite over hypotenuse. So square root of 21 over 5. And then the reciprocal is 5 over the square root of 21. But now, let's rationalize the denominator. Multiply top and bottom by square root of 21. So this will actually equal 5 square root of 21 over 21. Okay, tangent, opposite over adjacent. So that is square root of 21 over 2. And then its reciprocal, flip it, 2 over square root of 21. But rationalize the denominator. So it equals 2 square root of 21 over 21. So there are the values of all 6 trig functions when given this information about a right triangle. Okay, we're going to practice this one more time using tangent, starting with tangent. Tangent is equal to 1 over 2. So let's sketch a right triangle. Well, first, so tan, that's the TOA, opposite over adjacent. So we don't have hypotenuse, so I'm just going to do a side length 1 and then double that side length 2. Just getting a sketch on here. And if I make this my angle, opposite 1, adjacent 2, and I need to find the hypotenuse. So to find the hypotenuse, a squared plus b squared equals c squared. So 4 plus 1, 5 equals c squared, so c is equal to the square root of 5. So once I have all 3 sides, I can write all of the trig functions. So sine, cosine, tangent, and then their reciprocals. Reciprocal of sine is cosecant. Reciprocal of cosine is secant. And reciprocal of tangent is cotangent. Okay, let's start with the obvious one. We already have tan is 1 over 2, so flip it, cotangent is 2 over 1, or just 2. Okay, sine, opposite over hypotenuse, so 1 over square root of 5. Rationalize the denominator. So that would be square root of 5 over 5. And then if we flip this, cosecant is just square root of 5. Okay, cosine, adjacent over hypotenuse. So 2 over square root of 5. Rationalize the denominator. So 2 square root of 5 over 5. Secant is just this flipped, square root of 5 over 2. And there are all 6 trig functions. Okay, there's your full lesson on right triangle trigonometry. Good luck.